Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we'll discuss about a row echelon form. See, this is nothing new class, but you are going to understand the terminology that we are going to use in the linear algebra. In our previous classes, we clearly discussed about how to solve a system of linear equations, the basic method which we followed in our +1, +2 mathematics. That's exactly the same system, same method we are going to follow here, but we are going to understand the terminology, what is row operations and all those things. Please watch our previous classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, see the same example we are going to consider here. This is the system of linear equations which we considered: x minus 2y plus 3z is equal to 9, minus x plus 3y minus z is equal to minus 6, 2x minus 5y plus 5z is equal to 17. From this, we need to find the x, y, z value that solves all the equations. Means that satisfies all the three equations. Three equations are there, three unknowns are there. We are able to solve these equations. How we are going to do that? See, in our previous classes, example, what we have done? We have made these terms 0, this term, and this term. Why we made these terms zeros? So that we can use a back substitution method for solving the z value, y value and x value. The same thing here in row echelon form. We are going to make these terms zeros. In order to do that, operations to make these terms zeros, we are going to do some row operations. So what kind of row operations are allowed here, what are not allowed here? Let's try to understand. See here, when you multiply this equation with a scalar, means you take a constant value 2. Multiplying this equation with 2, it is not going to affect this equation. Whatever the equation you got, 2x minus 4y plus 6z is equal to 18. So this system of linear equations is same when you multiply this equation with 2. Similarly, when you add two equations, the output which we got after adding these two equations, first two equations, so solving the system of linear equations is same. So that's why we can do some row operations. What kind of row operations we are able to do here is row 1 can be multiplied with some scalar. Not only row 1, any row can be multiplied with some scalar. This row operation is allowed here because it is not affecting our system of linear equations. Even though you multiply with 2, our system of linear equations are same. Similarly, row 1 equal to row 1 addition or subtracting multiplied by scalar to row 2. Means you can do two row operations, plus or minus operations. You can add two rows or you can minus two rows, or you can multiply a scalar with a row and then add with the next row. Like this, you can do any kind of operations. It is not going to affect our system of linear equations. Similarly, you can add a scalar to a row. You take any row, you can add some scalar. R2 equal to R2 plus or minus, you can add or subtract a scalar plus or minus 2. So these set of row operations are allowed in our row echelon form. You can use these row operations in order to make these elements zeros. What kind of operations not allowed here? R1 tends to R1 multiplied by R2. Multiplication of two rows are not allowed. Similarly, division of two rows is not allowed. These two row operations are not allowed. Remaining operations are allowed. By using these row operations, we have to eliminate these terms. Now, the same example, how we are going to do that elimination. See, 1 minus 2, 3, 9. 1 minus 2, 3, 9. So the same equations written in the matrix form. This is matrix A, this is B. Combinedly we are writing here because we are doing row operations. These basic terms, AX equal to B, understanding is provided in our previous classes. Similarly, the second line, minus 1, 3, minus 1, minus 6. Minus 1, 3, minus 1, minus 6. 2 minus 5, 5, 17, third row. Now, in order to make this term 0, what row operation we can do to make it as 0? See, if you add these two terms, means row 1 plus row 2, you are going to get 0. Excuse me. So that's why the first row operation which we are going to do here is row 2 equal to row 1 plus row 2, means adding the two rows and placing them in row 2 value. 1 minus 1, 0. Minus 2 plus 3, 1. 3 minus 1, 2. 9 minus 6, 3. So these are the set of new linear equations, set of equations which we got after doing this row operation. Now you have to make this element as 0. If you want to make this element as 0, what row operations which we can do so that we can make it as 0? See, when you multiply this, the first row with minus 2 multiplied by 1 minus 2, add with row 3, you are going to get 0 here. So that's why row 3 is equal to minus 2 multiplied by row 1 plus row 3. You are going to get 0 here at this term. So minus 2 plus 2, 0. Similarly, minus 2 multiplied by minus 2, 4 minus 5, which is minus 1. Similarly, minus 2 multiplied by 3, which is minus 6 plus 5, which is minus 1. Similarly, minus 2 multiplied by 9, minus 18 plus 17, which is minus 1. So after doing this row operation, you got 0, minus 1, minus 1, minus 1. Now, which term you have to do? This term you have to make it as 0. In order to do this term, see, second row, this term, when it is added with the third row, you are going to get 0. So that's why R3 tends to R2 plus R3, row 3. That is what the row operation which we are going to do. 1 minus 1, 0. 2 minus 1, 1. 3 minus 1, 2. So these are the set of linear equations which we got after doing these operations. In this we made it as 0, 0, 0. And these diagonal terms, see here, these diagonal terms, we call it as pivot elements. So how we are going to use these pivot elements, in which way we are going to use these pivot elements, we are going to understand that in our coming classes. As of now, just remember these diagonal elements, we call them as pivot elements. So now it is in a row echelon form by making them as 0. Now we can back substitute, means 0x plus 0y plus 1z equal to 2, means z is equal to 2. So from this we got z is equal to 2. Now you can substitute z here. 2 2's 4, when this 4 comes to the other side, 3 minus 4, which is y is equal to minus 1. When you substitute z and y value here in this equation, you are going to get x is equal to 1. So the x, y, z values which you got, x is equal to 1, y is equal to minus 1, z is equal to 2. These are the values which are going to solve this, satisfy all these three equations. This is how we are going to apply row echelon form to solve the system of linear equations. We are going to do multiple examples in our coming classes. Hope you understand how we are going to use row echelon form to solve the system of linear equations. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.